A particle moves along an arc of a circle of radius r according to the law L is equal to a sine omega t, where L is the displacement from the initial position measured along the arc, and a and omega are constants. Assuming r is equal to 1 meter, a is equal to 0.8 and omega is 2 radians per second, we have to find the magnitude of the total acceleration of the particle at the points L is equal to 0 and at L is equal to plus minus a. And B part, the minimum value of the total acceleration a minimum and the corresponding displacement L minimum. Now what we have to find out here, we have to find out the magnitude of the total acceleration. So let's denote the magnitude of total acceleration by a, and we know that this a, the total acceleration in a non-uniform circular motion, is ac square, the square of the centripetal acceleration, plus the square of tangential acceleration. So under root of this centripetal acceleration square plus tangential acceleration square gives us the total acceleration at any instant of time or at any position. So in order to calculate this a, we need AC and we need AT. So from the given result, L is equal to a sine omega t, what we can calculate? We can calculate the speed at any instant of time. How? By differentiating this result. So if we differentiate this result on both sides, we will get v, that is equal to a, differentiating this sine omega t will give us omega cos of omega t. So this is our equation for v, and differentiating this equation for v, we get dv by dt, means we get the tangential acceleration, and differentiating this we will get minus a omega square sine of omega t. So we have the tangential acceleration value, and we know that the centripetal acceleration is equal to v square by r. So if we substitute this value of v from here in this equation, we get a square omega square cos square omega t divided by r. So at any instant of time, we have the formula for the total acceleration as ac square, means square of this term, that is a4 omega 4 divided by r square cos 4 omega t, plus square of this at is a square omega 4 sine square omega t. So we get this result for the magnitude of the total acceleration, but where we have to calculate it? We have to calculate it at L is equal to 0 and at L is equal to plus minus a. Now in order to find the value of a at these two values, L is equal to 0 and L is equal to plus minus a, we have two different methods to solve. So I am telling you both the methods. So the first method is to convert this equation in terms of L. So if you see carefully and transform this equation, so you can write here omega 4 divided by r square, and you can write a square. Instead of this a4, I am writing a square, and instead of writing this cos 4, I am writing cos square omega t whole square plus omega 4 a sine of omega t whole square. Clear? Now I am again changing this cos square omega t as 1 minus sine square omega t whole square plus omega 4 a sine of omega t whole square. And from here we know that L is equal to a sine of omega t, so we will change this a sine omega t in terms of L. So from here you can write, finally solving it, you will get omega 4 divided by r square a square minus L square whole square plus omega 4 L square. So we get the value of A. Now what we have to calculate, in the first part we have to calculate this value of A at L is equal to 0. At L is equal to 0. Now if we put L is equal to 0 in this equation, we get A is equal to L is 0, so it is omega 4 A4 divided by r square, and you will get A square omega square by r. And if we substitute the value of A, omega and r, we will get 2.6 meter per second square. And at L is equal to plus minus A, here as we are using L square here, so plus and minus will not affect the situation. Clear? So if we substitute this value of plus or minus A here, we get the value of A as this A square, and if we put L is equal to A plus or minus, so this will become 0, and finally we will get 0 plus omega 4 A square. Clear? And from here you get A omega square, and if you substitute the values of A and omega, you will get 3.2 meter per second square. So these are the two required results in part A of the question. Part A, we have to find the magnitude of the total acceleration at L is equal to 0 and L plus minus A. Now the another method is, if you look carefully, that for L is equal to 0, for L is equal to 0 in this equation, you will get 0 is equal to A sine of omega t. Now A cannot be 0, so from here we will get sine omega t is equal to 0. And squaring both sides here also does not affect the situation, so sine square omega t is 0. And from here you can also write 1 minus cos square omega t as 0, or cos square omega t equal to 1. So we have these two results, sine square omega t equal to 0 and cos square omega t as 1. And if you substitute these two values here in this equation for L is equal to 0, so you will get A for L is equal to 0 as cos square omega t. This cos square omega t is equal to 1, so this is power 4, so square of 1 will remain 1, so we get A4 omega 4 divided by r square plus sine square omega t, this is 0 here, so we will get A square omega square by r. And this is the same result we have calculated here. See, A square omega square by r. So we will get the same result, 2.6 meter per second square. And for L is equal to plus minus A, this means sine of omega t is equal to plus minus 1. Clear? So this shows that omega t is equal to plus minus pi by 2, and if you substitute the value again in the equation, in this equation, pi by 2, if you substitute the value pi by 2, you will get A for L is equal to plus minus A. So cos of pi by 2 is 0, so this equation, this part of the equation will become 0 and this part will become 1. So inside the under root we get A square omega 4, and solving this we get A omega square. Now see, this is the same result, so this will give you the same value. So either you can calculate through this procedure or through this procedure, it is going to give the same result. Now in the second part, B part, what we have to find out, we have to find out the minimum value of the total acceleration, this. So now this can also be achieved by differentiating this equation with respect to t, or you can get the same result by differentiating this part with respect to t. It's your choice. Clear? So I am differentiating this part, A is equal to this equation. So if I differentiate this result, and before differentiating I am squaring it on both sides, this is A square omega 4 divided by R square, A square minus L square whole square plus omega 4 L square. And if we differentiate it on both sides with respect to time, we get 2a dA by dt is equal to 2 omega 4 divided by R square. This 2 comes from here, A square minus L square, and differentiating this because L is a variable of time, so from here we get minus 2L, and differentiating this L, dL by dt gives you V, plus differentiating this part omega 4 2L dL by dt, so I am writing it as V. And in order to calculate the minimum value of A, we will put dA by dt as 0, and by doing this we get 2 omega 4 R square A square minus L square 2LV is equal to omega 4 2LV. Clear? So if we solve this equation, finally we will get L square is equal to A square minus R square by 2, and from here this L corresponding to minimum value, so I am writing L minimum is equal to A square minus R square by 2 under the root, and this is the required minimum value of L. And if we substitute this value of L in this equation, so that gives us A minimum as omega 4 divided by R square A square minus A square plus R square by 2 whole square plus omega square A square minus R square by 2. And if you solve it, you will get A minimum as A omega square 1 minus R square by 4A square. And substituting the given values for A and omega and R, you will get L minimum as 0.375 meters, and this A minimum as 2.5 meter per second square, and these are our desired results for the second part.